The LM317 is a popular adjustable linear voltage regulator. It was designed by Robert C Dobkin in 1976 while he worked at National Semiconductor. The LM337, a negative complement to the LM317, regulates voltages below, rather than above, the reference. It was designed by Robert Bob Pease. Specifications. Operation. As linear regulators, the LM317 and LM337 are used in DC to DC converter applications. Linear regulators inherently draw as much current as they supply. When this current is multiplied by the voltage difference between input and output, a significant amount of heat results. Therefore, the use of an LM317 commonly also requires a heat sink. For large voltage differences, the energy lost as heat can ultimately be greater than that provided by the circuit. This is the trade-off for using linear regulators, which are a simple way to provide a stable voltage with few additional components. The alternative is to use a switching voltage regulator, which is usually more efficient but has a larger footprint and requires a larger number of associated components. In packages with a heat-dissipating mounting tab, such as TO220, the tab is connected internally to the output pin, which may make it necessary to electrically isolate the tab or the heat sink from other parts of the application circuit. Failure to do this may cause the circuit to short. Voltage regulator equals. The LM317 has 3 pins: input, output, and adjustment. The device is conceptually an op-amp with a relatively high output current capacity. The non-inverting input of the amp is the adjustment pin, while the inverting input is set by an internal band gap voltage reference which produces a stable reference voltage of 1.25 V. A resistive voltage divider between the output and ground configures the op-amp as a non-inverting amplifier so that the voltage of the output pin is continuously adjusted to be a fixed amount, the reference voltage, above that of the adjustment pin. Ideally, this makes the output voltage, Vout equals VRF, because some quiescent current flows from the adjustment pin of the device. An error term is added, Vout equals VRF plus IQRL. To make the output more stable, the device is designed to keep the quiescent current at or below 100 microampere, making it possible to ignore the error term in nearly all practical cases. Current regulator equals. The device can be configured to regulate the current to a load, rather than the voltage, by replacing the low side resistor of the divider with the load itself. The output current is that resulting from dropping the reference voltage across the resistor. Ideally, this is IOT equals for RH, accounting for quiescent current. This becomes IOT equals plus IQ. LM317 can also be used to design various other circuits like 0V to 30V regulator circuit, adjustable regulator circuit with improved ripple rejection, precision current limiter circuit, tracking pre-regulator circuit, 1.25V to 20V regulator circuit with minimum program current, adjustable multiple on-card regulators with single control, battery charger circuit, 50 mA constant current battery charger circuit, slow turn-on 15V regulator circuit, AC voltage regulator circuit, current limited 6V charger circuit, adjustable 4V regulator circuit, high current adjustable regulator circuit and many more. Compared to 78XX/79XX, the LM317 is an adjustable analog to the popular 78XX fixed regulators. Like the LM317, each of the 78XX regulators is designed to adjust the output voltage until it is some fixed voltage above the adjustment pin. The mechanism used is similar enough that a voltage divider can be used in the same way as with the LM317, and the output follows the same formula, using the regulator's fixed voltage for VRF. However, the 78XX device's quiescent current is substantially higher and less stable. Because of this, the error term in the formula cannot be ignored and the value of the low side resistor becomes more critical. More stable adjustments can be made by providing a reference voltage that is less sensitive than a resistive divider to current fluctuations, such as a diode drop or a voltage buffer. The LM317 is designed to compensate for these fluctuations internally, making such measures unnecessary. The LM337 relates in the same way to the fixed 79XX regulators. See also, band gap voltage reference, Precore band gap reference, list of LM series integrated circuits. References. External links, LM317 circuit schematics and pinouts, online calculator to pick resistors for LM317 circuit, band gap, the design of band gap reference circuits, trials and tribulations Robert Pease, National Semiconductor, LM317 band gap voltage reference example brief explanation of the temperature-independent band gap reference circuit within the LM317. IC datasheets, voltage regulator databook, National Semiconductor, LM317, LM350, Texas Instruments, LM317, LM350, ON Semiconductor, LM317, ST Microelectronics, LM337, Texas Instruments.